Welcome to today's lesson. We are going to look at effects of force. The first one, we have that it can make stationary object move. And in here, when we talk of stationary object, it is an object that is not moving. Look at an example when you have a ball that is just lying on the ground and then you kick it. The ball was not moving, but by kicking it, you have started the motion. So you have made that stationary object to move. You can increase the speed of a moving object. It can stop a moving object. For instance, you have a ball that was rolling and then you apply your feet and then you block it. Then you say that you have stopped that moving object. It can decrease the speed of a moving object. It can change the shape. When we talk of the changing the shape, I want us to look at maybe when you are dealing with the plasticine, or you are working with the clay, or you are cooking chapati. You can shape those doughs to the shape that you want by applying force. This is how you are able to change the shape of an object. Then it can make an object to turn about a fixed point. When you are closing or opening your door or your rockers, that point that is fixed where we have the hinges. You find that by applying that force, you always turn that door or that rocker at that particular point. That is what we call the turning effect of a force. It can change the direction of a moving body. You are in the field, 11 of you, playing football. Can you try and imagine the movement of that ball? It's kicked by your opponent, you kick it, your friend kicks it. You find that you can't even describe the motion of that ball. And it is being made to change by the application of the force. So force can change the direction of a moving object. Then we move to mass, weight, and their relationship. And we start with the definition of mass. As we have seen earlier, mass is defined as quantity of matter in a body. And we know that matter is anything that has mass and occupies space. So if you are able to subdivide and get all the particles in the body, then you are counting the mass, quantity of matter in a body. Weight is a gravitational pull on a body towards the center of the earth. In other words, this is what we call the gravitational pull or gravitational force on earth. The pull, the attraction towards the center of the earth. The SI unit of force and their units is Newton. Remember, weight is force. Therefore, the SI unit of weight is Newton, and the symbol is capital N. Weight is measured using spring balance, and this spring balance is graduated or it is calibrated in newtons. Due to the shape and rotation of the earth, we find that weight varies from place to place, but mass is constant. Mass does not change, but weight changes. As you move from one planet to the other, you find that due to the shape and the rotation, you find that weight will vary. Then we are saying that the earth is not a perfect sphere. And as you are going to see, or when you are studying geography, you find that it is flattened at the poles. And therefore you will find that the distance between the center of the earth and the pole is shorter than the distance between the center of the earth and the equator. And therefore a body will weigh more at the poles than at the equator. Then we have to move to the relationship between mass and weight. On the earth's surface, an object of mass m has a gravitational pull of mg. mg refers to mass times gravitational constant, or what we are going to see, acceleration due to gravity. Therefore, mathematically, weight is equals to mass times acceleration due to gravity g. So we have W is equals to mg. What is acceleration due to gravity? This one we say that it is the force acting on a unit mass on a place. So with that formula, we can be able to have a graph When you plot a graph of mass or a graph of weight against mass, that is, on the y-axis you have weight and on the x-axis you have mass. This graph is a straight line and it is passing through the origin. When you get to the slope, and when we are talking of slope, it is the same as gradient, where we get the change in weight and the change in mass. When you get the slope will give us acceleration due to gravity. The SI unit of gravitational field strength, or what we are calling acceleration due to gravity, is Newton per kilogram, written like this. Then we move to differences between mass and weight. We have mentioned some, but we have the first one. The mass, by definition, is quantity of matter in an object, while weight is gravitational pull on the object. Then we have seen that the SI unit of mass is kilogram, but now weight is a force and therefore the SI unit is Newton. We have also mentioned that mass does not change. It is constant everywhere, but weight varies from place to place. This one has magnitude alone, and therefore it is a scalar quantity. But weight, being a force, has both magnitude and direction, and therefore it is a vector quantity. Then finally, mass is measured using beam balance, while weight is measured using spring balance, that is calibrated in newtons. Then we move to an example. State a reason as to why weight of a body varies from place to place on the Earth's surface. As we have mentioned, we have said that weight varies from one place to the other. And the reason as to why it varies, it's because of gravitational field strength, the acceleration due to gravity. It varies from one place to the other. We have also said that when you move from equator, or when you move from the poles or towards the equator, the Earth is not a perfect sphere. And this is what is causing the gravitational field strength to vary. And when it varies, it changes the weight of that body. Then we have another calculations here. We have an object weighs 1,000 Newton on the Earth's surface. Calculate its mass. We have this formula, weight is equals to mass times g. We always say that you start with the formula, then substitute. We have 1,000 Newton. We have mass, that is what we are looking for, so we write m, and we have our g, which is 10 Newton per kg. So by dividing, remember we want to get m, so we divide. By dividing, you find that this Newton and Newton will cancel, 0 and 0 will cancel, you are left with 100 kg. So the mass is 100 kg, like that. So you will move to another example. If the same object weighs 160 Newton on the moon's surface, find the gravitational field strength of the moon. We have calculated the mass and we are given the weight. Therefore, we start with the formula. We substitute the values, that is 160, and the mass is 100, and then we have g. Now to get g, we divide through by 100. So by dividing by 100, you have 160 divided by 100, you have the decimal point will move 2 steps. So it becomes 1.60 Newton per kg. Then we have another example. A mass of 7.5 kg has a weight of 30 Newton on the surface on a certain planet. Calculate the acceleration due to gravity on this planet. Again, we start with the formula. We substitute the values. We have 30 Newton. We have 7.5 kg. We are looking for g. So you divide, it becomes 4 Newton per kg. Then we move to another example. You have a man that has a mass of 70 kg. You are supposed to calculate his weight on Earth, where gravitational field strength is 10. We start with the formula. Weight is equals to mass times g. Then we put the values. Our mass is 70 kg. Our g is 10, so you get 700 Newton. His weight on moon where gravitational field strength is 1.7 Newton per kg. So what has changed is the gravitational constant. Therefore, we substitute 70 times 1.7, you get 119 Newton. So you find that this body or this man will weigh less when he is on moon. Then we move to scalar and vector quantities. We start by defining. A vector quantity is defined as a body or a quantity that is well described using magnitude and direction. Or in other words, we say that it is a quantity that has both magnitude and direction. And we have examples: weight, force, velocity, momentum, acceleration, displacement. All these, they have both magnitude and direction. Then we come to scalar quantity. These one are quantities that are fully described by magnitude alone. In other words, we are saying they are quantities that have only magnitude but no direction. Examples are time, temperature, energy, speed, area, and many others. So we move to an example. You have that if the weight of a car is 800 Newton, that is the weight of the car. 8,000 gives the magnitude, that is the size. Then N is the SI unit. And because it is the weight, the direction is towards the center of the earth. So in other words, we can say that the weight is having both magnitude and direction. It is a vector quantity. So we come to resultant vector. This is the sum of two or more vectors taking into account the direction of the vectors. Remember, vector has direction. So it means when you are adding them, you consider the direction. We can have an example here. You have two forces that are acting in the same direction. You have 5 Newton and 4 Newton. Now to get the resultant, because they are acting on the same direction, we take that direction to be positive and therefore we add. So we have positive 4 plus positive 5, you get positive 9. So our resultant will be larger like this because you have added the two. Remember, the length of the arrow represents the magnitude. So by combining the two, then this should be larger than both of them. Then we look at another example. You have 4 forces that are acting in different directions. So to get the resultant, we consider these ones that are acting in this direction to be negative. So we have negative 7 plus negative 3. Then these other ones, we take them to be positive. We have positive 2 and positive 4. Therefore, when you add this, it will become negative 10. Then when you add this, you get positive 6. So when you add them, you'll find that it will give you a final answer of negative 4 Newton. So when you're drawing, remember the negative shows this direction. So it means that the resultant will be towards this direction, 4 Newton. Then you have a quiz. Quiz yourself. If you look at these questions, most of them are you're supposed to define, others you're supposed to calculate. So revise thoroughly before you attempt and make sure that for the definition, don't recopy from your notes or from the slides. Ensure that you're getting the answers from your head. Work hard and know that the sky is the limit. Thank you and prepare for the end of topic exam.